Let's study the continuity of a real valued function. For the sake of understanding of this section, check the description box below to learn the previous topics before this. Alright, what is the condition for a function to be continuous? When we say a function is continuous, what are the conditions that ensures continuity? Now, let me say a function f of x. Pay attention to this. A function f of x is said to be what? Is said to be continuous. A function f of x is said to be what? Is said to be continuous at, let me say, at a point x equal to a, if it can satisfy these three conditions. Again, a function f of x is said to be continuous at x equal to a if it can satisfy this condition. Number one, the left hand limit must be equal to the right hand limit. What am I saying? This is it. The left hand limit, for example, the limit as x tends to a from the left of f of x must be equal to the limit as x tends to a from the right of f of x. This is the meaning. The left hand limit must be equal to the right hand limit. Now, if it satisfies, this is a necessary condition, but it is not sufficient. If left hand limit and right hand limit are equal, good. Does that mean the function is continuous? No. Next one. What is the next condition for the function to be continuous? The next one is that what? F of a must be defined. You can see is a must be defined. It means that f of a must be a function that is defined. It must be what? It must be finite. It must make sense. Okay, good. It must be defined. Not that I'll have a function that will give me, okay, let me say infinity. For example, if I have a fraction giving me over 0, this is not defined. This is not what I'm talking about. It must be defined. It must be finite. Also, next one. The last one is that what? The limit at x tends to a negative of f of x, we already know is equal to the limit as x tends to a positive of f of x. Then, since these two are equal, they must be equal to f of a. This thing means that the limit as x tends to a of f of x must be equal to f of a. If you can satisfy these three conditions, then a function is said to be continuous. The first one, left hand limit must be equal to right hand limit. The second one is that f of a must be defined or must exist. Must be defined or what? Or must exist. And also the limit must be equal to the value f of a. That is, the limit of the function as that x approaches a must be equal to the value of function at x equal to a. If this is satisfied, then the function is said to be continuous. Now, let me say a function is not continuous. If a function is not continuous, it means that the function is discontinuous. It means that the function is discontinuous. So, if this function is not continuous at x equals to a, we will say that well, the function is discontinuous at x equal to a. It means that x equal to a is a point of discontinuity. It means that what x equals to a is a point of discontinuity. That is it. And discontinuity is divided into what? How many? 3. If a function is if a function is discontinuous, it's divided into how many parts? 3 parts. Number one, we have what we call the jump discontinuity. First one, we have what we call what? The jump discontinuity. We have the jump discontinuity. What is jump discontinuity? If you are checking for your conditions here, if this first function is not satisfied, that is, if the limit as x tends to a negative of f of x is not equal to the limit as x tends to a positive of f of x, it means that this function has a jump discontinuity. Next one, another type that we have is what we call what? Infinite discontinuity. Infinite discontinuity. All right, what's infinite discontinuity? That is, if your limit as x tends to a negative of f of x gives you something like positive plus or minus infinity, or you have your limit as x tends to a positive of f of x is giving you either of this infinity. Then we have infinite discontinuity. Discontinuity. It makes sense because from the name you get the concept. And the last one is what we call the removable discontinuity. The removable discontinuity. And what is the removable discontinuity? This is what we have. If the limit exists, that is, if the limit, firstly, if the limit, that is, I'm coming, the removable discontinuity is this. The limit exists, the limit exists, but it is not equal to f of a. That is, this third condition is not satisfied. That is, the limit as x tends to a of f of x is not equal to f of a. So this type of discontinuity is called removable discontinuity. We call it removable discontinuity because it's easily removable if I redefine x. If I can redefine f of x, then it could satisfy what this condition. Now we've known all this. Now, what are other things we need to know before we start solving question? Other thing is that, let me say f and g are continuous. For example, if I say f of f and g are continuous, you see the sum or the difference of these two functions are also continuous. Are also continuous. If f and g are continuous function, it means that the addition and subtraction of these two functions will also give you an answer that is continuous. Similarly, the product are also what? Continuous. And also the quotient, if I divide them, they are also continuous provided g is not equal to 0. Provided g is not equal to what? 0. So that is it. Now we've learned all the concepts of continuity. Now let us go ahead and solve question. Please take note of all this. We are going to be using it. All right. Okay, let's look at the first question. Okay, let's see. Let's first check f of x is equal to the absolute value function, absolute value of x. Let's see. Is this function, is this a continuous function? Is f of x continuous? Let me just see at s equal to 0. Let's see, is it continuous at s equals to 0? Let's see. If I define my absolute value function, we already know that it's what? X if x is greater than 0 and negative x if x is less than 0. Let's see. Is this continuous? Okay. Firstly, I can just determine this by, okay, let's see. We already know that what the first condition is that what the limit as x tends to 0 minus of, let me write the definition. The limit as x tends to a negative of f of x must be equal to the limit as x tends to a positive of this same f of x. That's the first condition, that left-hand limit must be equal to right-hand limit. Let's see. What's my left-hand limit here? Remember, the left-hand limit as x approaches 0 from the left is that, you see, I told us, watch my previous video on existence of limit and one-sided limits to know how to evaluate this. The link is in the description box below. Now, I have limit as x tends to 0 minus. Which of these function will I pick? Remember, 0 minus means that I'm considering value where x is slightly less than 0. And this is what we call the less than 0 here. This is less than 0. This is less than 0. All right. So let's say less than 0. So this is what I have. So I'm picking negative x because that's where I have less than 0. So if I put my value here, I'll be having that's equals to minus 0 and my answer is 0. Also, if I look at the limit where x tends to 0 plus of this function positive x, what will I have? Positive 0 and my answer is 0. Now, left-hand limit is equals to right hand limit. Okay, let's see. Is Let's look at f of a. Is f of a defined? What's f of 0? F of 0 is absolute value of 0 and my answer is equals to 0. It's defined. Good. And also, is the limit as x tends to 0 of this absolute value function, is it equal to the value of this f of 0? That is, see, if the limit as x tends to 0 of f of x, is it equal to this f of the last condition? Are they equal? Let's check. What's the limit as x tends to 0 of f of x is what? 0. And what f of 0? 0. Now, since this holds, then this value here is continuous. Yeah, it's continuous. It's continuous. Also, if I show you graphically, if I plot this graph, this is what I'm getting. This is the graph of the absolute value function like this. Like this. You can observe, this is my 0, the origin of the graph. You observe that normally, if I check the limits from the graph, if I approach it from the left or from the right, they are both tending towards 0, so the limit is equals to 0. Okay, and if you observe, it's continuous. I don't have any break on the graph. The graph is not broken, so it is continuous. Yeah. So let's look at another question. Now, let's look at this. Suppose you are given f of x to be like this. X squared if x is less than or equal to 1. And 4 minus 3x if x is greater than 1. Let's see. Is f continuous at s equals to 1? Is f continuous at s equal to 1? That's the question. Okay, let's see. Solution. Firstly, let's check the limits. When x approach 1 from the left of function f of x. And remember, which of the f of x will I be picking if x approach 1 from the left? Remember, I'm looking at values that are less than 1, so I'm picking x squared. And remember, 1 negative does not mean minus 1. So from here, I have 1 squared and my answer is equals to 1. I've gotten that. Next one, let's look at the limits as x approaches 1 from the right of f of x. Remember, if x approach 1 from the right, I'm looking at values of x greater than 1. And here we have greater than 1. So the function there is 4 minus 3x. So this is what I have. So what do we have? We have 4 minus, if I direct substitute this one, 3 times 1, and that's 4 minus 3, and that's equals to 1. So left hand limit is equal to the right hand limit. So the first condition is satisfied. Now let's look at other condition. Let's see. What is f of 1? Now, what is the value of the f of x at x equal to 1? That's the meaning of this thing. Now, look at these two. Where do we have s equal to 1 out of them? Check. Where do we have s equals to 1? Check it out. This is a piecewise function that has been defined for you. Where do we have s equal to 1? See, this is it. Greater than or equal to 1. So this is where I have what? Equal to 1. So I'll be saying, so I'll be picking, so the f of x here I'll be picking. So f of 1 here, so the f of x I'll be picking, where I'll be inputting this one, will be this s squared. So I have 1 squared, and that's equal to 1. And observe, my limit, where x tends to 1 of f of x is equal to f of 1. Both of them give me 1. You can see, my limit here gave me 1, and my value of my f of 1 also gave me 1. And also f of 1 equal to 1 is defined, it exists, it's finite. And what happened? Therefore, this f is continuous. And that's it. Next question. Now, what's the next question? The next question is this. Let's look at another question. If f of x is defined as this, I have s cubed plus 1 over x plus 1, and I have 3. Here, x is not equal to minus 1, and here, x is equal to minus 1. Let's see. Is this continuous at s equal to 1? Is it continuous? If you observe this question, there's nothing like s greater than 1, x less than 1. Nothing is not there. but it is there automatically. The meaning of this thing, x is not equal to 1, it means that if x is not equal to 1, it means that is either x is greater than 1 or x is less than 1. That's the meaning. So it means that here, for my x approaching -1 from the left and -1 from the right, I'll be using this same function because here is where x is less than 1. Also here is where x is greater than 1. So here I will not be writing left hand limit, right hand limit. I will not be wasting my time. Firstly, what I'm going to do here is just find the limits automatically. I'll just find the limit as x tends to -1 of the f of x here. Why am I doing this? Why am I not doing left and right? Left and right will still give me the same thing because this is the left, this is the right. Like it's embedded here already. So I'm just having the same function for both of them. So I'll just find the limit. This has combined those two together already. Whenever you see this, this is what you should do. So I have the limit as x tends to -1 of x cubed plus 1 over x plus 1. How do we solve this? If I put my -1 here, I'll be having, here will give me -1 plus 1 over -1 plus 1, and that's 0 over 0. And remember, 0 over 0 is a condition for L'Hospital rule. That's what I want to use. I can use factorization method, but let me use L'Hospital rule to evaluate this. So I have limit as x tends to -1. So what will I have here? If I differentiate each of the term, 3x squared, this will give me 0 over, this will give me 1. So substitute, what we have, 3 minus 1 squared, and my answer is equals to 3. It means that after evaluating the limit, I got 3. Now, what is the value of the function? What is f of -1? What's f of -1? Can you tell me what is the value of f of x as x is equals to 1? You can see here they define s equals to 1 for you here also. And what is the value of f of x as s equals to 1? It is equal to 3. You can say equal to 3. So my answer is 3 here. So you can say the limit is equal to what? This. Therefore, f is continuous. And that is it. So we have f is continuous. So that's how to test for continuity. So the question we have been solving are straightforward enough. So let's see. Let's dabble into some kind of problem. All right. Let's see. Um, if I have f of x to be this, x plus 1, ax plus b, 3x. Here x is less than 1. Here 1 is less than or equal to x, less than 2. And here x is greater than or equal to 2. This is the piecewise function defined for you. Now, find the value of a and b for which f is continuous. Okay? They told us f is continuous. It means that it will be continuous at 1, also continuous at 2. So they told us f is continuous. So continuous everywhere. All right. So it's continuous within the interval given here. So let's see. What's the value of a and b for which f is continuous? Okay, firstly, let me check the continuity at s equals to 1. Okay? Firstly, at x equal to 1. So let me check the continuity. So let me look at the limit. Remember, we'll first check the limit also. The limit as s equals to 1 from the left of f of x. What will I have? The limit as s equal to 1 from the left. Now, which of the function will I pick? 1 from the left means less than 1, and this is what I have. So x plus 1. Remember, 1 minus does not mean -1, it means 1. So I have 1 plus 1, that's equals to 2. Good. And what is the limit? As s equals to 1 from the right of f of x. So what will I have? S equals to 1 from the right of f of x. So what will I be picking? Okay, 1 from the right means s greater than 1. Where do we have s greater than 1 here? Don't panic. See where we have s greater than 1 here. See what we have here. 1 less than or equal to s. This means s greater than or equal to 1. So this is where we have greater than 1. So I'm picking this function, ax plus b. So if I put 1 there, I will have a times 1 is a. So that's a plus b. Good. Okay. For continuity, the limit must hold. So for continuity, left hand limit surely must be equal to right hand limit. Yeah, it must satisfy it. That is, a plus b must be equal to 2, equation 1. Also, I will be checking the continuity at s equals to 2. Okay, because x equals to 2 is also part of this. So let me be checking the continuity as s at s equal to what? 2. Alright. At x equal to 2. So let's go. So I must check the limit at x tends to 2 from the left of f of x. So what do I have here? The limit as x tends to 2 from the left of which function? Now, 2 from the left means that x less than 2. So it will tell you the function you are picking. So where do we have x less than 2? This is it here. So I'll be picking this function. So I have ax plus b. So I have this, if I put my 2 here, so I have 2a plus b. That's the limit where x approach 2 from the left. Also, check the limit where x approach 2 from the right. That's where you have x greater than 2, and this is it here. So you have 3x, and that's 3 times 2, and that's 6. Let me show you the working fully. Now, for continuity, what happens? Left hand limit is a must also be equal to what? Right hand limit. And what will I do here? That is 2a plus b. Left hand limit must be equal to 6 right hand limit, equation 2. Now, I believe you are matured here. So let's solve this equation simultaneously. That is, subtract equation 1 from 2. That's subtract equation 1 from 2. That's remove 1 from 2. So let me say 2a minus 2a will give me a. B minus b will give me 0. 6 minus 2 will give me 4. A equal to 4. So substitute a equal to 4 in equation 1. And that will give me 4 plus b equal to 2. My a is now 4. Therefore, b will be equal to 2 minus 4 and b will be equal to minus 2. So a is 4 and b is negative 2. So that is it on this type of question. All right. I believe you are following. Please kindly comment. That's part of the way you can help me grow so I can be motivated to give you more top-notch videos. All right, next one. We discuss type of discontinuity. So let us look at some questions and let's see what type of discontinuity do we have in such questions. So let's see what type of discontinuity. Remember, I discussed that we have jump discontinuity. We also have what we call the we have the removable discontinuity and we also have the infinite discontinuity. So let's see a question that will actually have jump discontinuity. Okay, let's see. Okay, let's see. If I have this function f of x, which is equal to 1 minus 3x, 7, x squared plus 2x minus 3. Here, if you have x to be greater than minus 2, if x equal to 0, if x is less than minus 2, check if f is continuous. They did not tell you what point to check if s is continuous, but yeah, our common sense will tell us that. Let's see. 2 here is the one that is even more defined. I have 2 from the right. I also have 2 from the left. So I'll check the continuity at s equals to 2. So at s equal to 2, let's see if f of s is continuous. We check the limit as s approaches 2 from the left of f of x. So I have the limit as x approaches 2 from the left of what is my f of x from the left. And that is it. So I have x squared plus 2x minus 3. And that's equal to 2 squared plus 2 times 2 minus 3. 4 plus 4 minus 3, and that will be equal to 4 plus 4 is 8, minus 3 is 5. All right. Check the limit also from the right of 2 of f of x. From the right, I'm looking at x greater than 2, and this is it here, 1 minus 3x. And what will I be having? 1 minus 3 times 2, and that's 1 minus 6, and that's minus 5. Here, left hand limit is not equal to the right hand limit. So f is discontinuous at s equal to 2. If f is discontinuous at s equals to 2, what does that mean? It means that s equals to 2 is a point of discontinuity. And what type of discontinuity is this? So we have what? Jump discontinuity. Jump discontinuity. So that's the type of discontinuity we have here. So it is jump because left hand limit is not equal to the right hand limit. Similarly, let's look at another question. If I have the limit as x tends to, let me say, as x tends to 0, let me say 0, then of 1 over x. Let's check the continuity of this at x equal to 0. Let's see. Don't panic. Let's solve this. So if I have the limit at x equal to, as x tends to 0 from the left of 1 over x. Now, you see, if x tends to 0 from the left of 1 over x, the answer to this will give me, remember, I'm checking values that are less than 0, which means that I'm looking at negative values. Remember, I'm looking at negative values less than 0. And looking at this, remember, if I'm dividing by 0, it will give me negative infinity. So it will give me infinity if I'm dividing by 0. But here I'm going like 0 from the left. And remember, if I'm looking at 0 here, 0 from the left is giving me what? Negative values. Therefore, what I'm getting here will be negative infinity. And also, if I have the limit at x tends to 0 positive of 1 over x, this one I'm having 0 to the right. So I'm having positive infinity. So what type of, is x continuous here? No. X is discontinuous at x equals to 0 and it has infinite discontinuity. Just if you can have infinity in any of them, conclude infinite discontinuity. And also, let's see another type. If I have f of x to be equal to x squared plus 3x, here I have negative 1. Here, if x is not equal to 1, and here if x is equals to, sorry, it should be negative 1. I'm coming. If x is not equal to negative 1 and if x equals to negative 1, let's see. Remember I told us that whenever we are having this, no need of doing left to right. Just carry out your limits that way. Anything you get here is both for left and right. So as x tends to minus 1 of your function f of x, so which are you picking? This. X tends to minus 1 of f of x. So what we have here, sorry, what is my f of x? I'll have it to be x squared plus 3x minus 1 square plus 3 times minus 1. That gives me 1 minus 3 and that's minus 2. And also, what is the, I want to test for continuity now. I also need to test that value, f of a, and my a here is minus 1. What's f of minus 1? When s equals to minus 1, what's the value of f of x? You have minus 1. So you can say the limit exists, but the limit as x tends to a of f of x is not equal to f of a. Is not equal to f of a. So what type of discontinuity is this? This is what? Removable discontinuity. Yeah. So that is that about that on this continuity. Please, thanks for watching. Try to share this video around. Like, comment, share, subscribe, and click the notification bell. Thanks for watching. Much love, guys.